This is Geometry Semester 2. It's the second unit here called Special Right Triangles, and this is the third lesson inside of it. This name of this lesson is 30, 60, 90 Hypotenuse Practice. That's the name of the lesson. It's in Creator Math. It's under the Geometry tab. The instructions are copy the following problems 1 through 8 into your composition book on the correct pages according to the table of contents, with the notes for those pages, which make sure you're getting that from the table of contents and adding that in too. These problems, when I solve them, I explain some things, but I don't explain all the notes. You still need that in the comp book. From creatormath.com under the Geometry tab. So the first one says, given a right triangle with one 30-degree, this is just going to ask us more 30, 60, 90s, just like the prior lesson, all right, the side across. So let's draw in the same pattern that we did on that one too. 30 degrees. If this is 30, this has got to be 60 degrees. Why? Because all the angles of a triangle must add up to 180. So it's a right triangle. It's got a 30-degree angle. The side across from the 30 is 10. So we're going straight across. This one's 10. What is the length of the side across from the 90? That would be across here. So let's just revisit the pattern, the ratios of a 30, 60, 90 triangle. Given a 30-degree angle here, across from that's x. The hypotenuse is 2x. And across from the 60 angle across here is x times the square root of 3. That pattern plays out every time. So if you tell me this side's 10, I match that up with the x, and I say x equals 10, and then you ask me how long is the hypotenuse. Well, it's 2 times 10, because it's 2x, 20. And I might be going a little fast, but this is the third lesson on this, right? So go back and look at the other lessons. I go a little bit slower on those. Given a right triangle with one angle 60 degrees, the side length across from the 60 is 15. What is the length? So let's draw this. Keep it in the same orientation I like. No reason to go rotating this unless we have to. It starts to get more complicated if we spin it around. So we got a right triangle, we got a 60-degree angle. The side length across from the 60 over here is 15. All right, so then it's saying what is the length of the side across from the 90? So they want to know this one here, question mark. So what we do is match up the side they gave us. They gave us 15 right here, and we know that that matches with the x radical 3. So we're going to say x squared root of 3 equals 15. Divide both sides by square root of 3. This one is going to require rationalizing the denominator, which means multiplying this by square root of 3 over square root of 3, which is 1. 15 square root of 3 across the top, over square root of 3 times square root of 3 is square root of 9, which simplifies to 3. So 15 square root of 3 over 3. 15 divided by 3 is 5, so we know that x equals 5 times the square root of 3. If x equals 5 times the square root of 3, that's this side, x. This side, the hypotenuse, is 2x, again, according to our model. So all we have to do is take 2 times this 5 square root of 3, and it comes out 10 square root of 3, or 10 square root of 3. And it might say radical too. It might say 10 times radical 3. Radical and square root are synonyms. You can use them interchangeably. Given another right triangle, here's 30 degrees. Let's keep our same orientation. It's a right triangle. It's 30 degrees. The side length adjacent to the 30, that's this one here, is 12. All right, what is the length of the side across from the 90? Same thing, they just asked us, but they gave us a slightly different number. We're going to take x square root of 3, which matches up with this side, put it equal to the 12, do some algebra to see what x equals. In other words, isolate the x. These cancel, now the x is alone. I have to rationalize the denominator because I am not allowed to have a square root in the denominator. I'm going to get 12 square root of 3 on top. Square root of 3 times square root of 3 is square root of 9, which simplifies to 3. 12 square root of 3 on top. This x equals 12 divided by 3 is 4, and you still have the square root of 3. So x is 4 times the square root of 3. That would be this side here, which is x. According to my pattern, I need the hypotenuse, which is 2x. So multiply 4 square root of 3 by 2, and I get 8 square root of 3. So this side would be 8 square root of 3 long. Given a right triangle with 60 degrees, all right, draw another. These are quite repetitive, and that's part of the purpose, so you can have some shot at getting these when you do them. Given the right triangle with one 60-degree angle, there it is, so I got a right triangle, I got a 60-degree. The side length across from the 60 is 21. Same problem they're giving me again. What's the length of the other two sides now? They want to know this one and this one. So we know this side matches up with the x square root of 3. So we literally say they're equal. X square root of 3 equals the 21. Okay? Divide both sides by square root of 3. Very repetitive now. Rationalize the denominator. This is 1. So we got 21 square root of 3 on top, square root of 9 on the bottom, 21 square root of 3 on the top, and 3 on the bottom. 21 divided by 3 is 7, so we get x equals 7 square root of 3. That's going to be the answer here. And this one over here is going to be 14 square root of 3 because it's double that. It's 2x. X and 2x, and we found x, so we just double it for the hypotenuse. So we get 7 radical 3 for one and 14 radical 3 for the other. Given the figure below, what's the length of the hypotenuse? Oh, this is interesting. Given the figure below, what's the length of the hypotenuse? Well, first of all, hypotenuse is the longest side, and it's across from the largest angle. This is the largest angle. It's got to be here. Now, it can't be this one because this is a leg, and this one is a leg. Remember, a triangle has two legs like a human, and the two legs are attached to the largest angle. So this is the hypotenuse right there, and it looks like that's all they want us to answer. 2a. And remember, we used x, 2x, and x times the square root of 3. This is just a different variable, a, 2a, and a times the square root of 3. Don't let it, bother you too much. They're just using a different variable. It's still totally valid. Given a 30, 60, 90 special right triangle, what is the measure of the side across from the 30? So they're just going for the pattern. Let me draw the pattern once here. I know I'm on the problem below, but it looks like they're going to ask me this all over again. This is x, this is 2x, and this is x radical 3. So what's the measure of the side across from the 30? Go across from the 30, x. Given a 30, 60, 90, what's the measure across from the 60? X times the square root of 3. They're just asking us about the pattern, which is the same every time. Given a 30, 60, 90, what is it across from the 90? 2x. Done. Make sure you're looking at the notes on creatormath.com under the geometry tab, under this unit and lesson. The unit is special right triangles. The lesson is lesson 3, 30, 60, 90 hypotenuse practice.